explain about a robotic project that how we will program a robotic arm to perform precision tasks such as picking up objects and placing them into designated target location. So we'll do the entire programming in Matlab. So I already developed it. I will explain patch by patch about the code and how you will design and also show you the model that we developed. So let's what we are planning to design. Let's so this is the design. So this is if you are seeing like we have designed a robotic arm which is picking three different blocks and then taking it from one table to another table. So if you see this here it is picking precisely red block and then placing it in from one table to another table. Similarly, it will take the other two blocks which are blue and green. So this is something that we are going to plan. Now the code, now I am taking you to the code that we have developed. So here if you see this is the code. So this is the code. If you see it is the detailed code which I am going to explain patch by patch like what does it mean, how you will do it. Okay, so let's come back. So basically this is the MATLAB code which we have designed to control a UR10 robotic arm in a simulated environment. Likely VRAP which is called a Copperlia sim. So I already show you the model that we have developed. Now let's break the code section by section, line by line. So if you see here, uh, so here if you see this is like pick and place dot am code. This is standard MATLAB comment. Okay, so it shows about what it is, what is different sections, all those things. Now coming to the main part of the code. Okay, so here if you see these are the code with comments and all. So this section is also like comment block explaining the different things like what we have to install, like it emphasizes the dependency on Peter Cox MATLAB robotic toolbox and explain how to install it, which is either by downloading from the URL or by double clicking the MATLAB box file if it is available in local folder. Now let me check whether my connection is okay. Yeah, it is working. Now moving again. Yeah, so now moving on to the MATLAB main files. Okay, if you see the code, these are the codes. Next patch, and this section deals with setting up the MATLAB path. So the strip entire script can find necessary functions. So here if you see we have add path and add path vrap connection. So add path adds the parent directory of the current script to the MATLAB path, whereas add path with vrap connection it adds multiple specific subdirectories to the multiple path. These directories likely contain functions related to vrap connection, which we also call copper lithium connection utility. Am function, robotic function, am function, URN functions, am function, vref function. Now MATLAB vref equal to rampy. These are the next batch of code you see, and it this section these line establishes the connection into the vref simulator. So basically it is linking to the simulator. So first command vref ram mpi remote API, it initializes the remote API object which is basically the class that provide function to communicate with vref. This lines essentially creates an instances of that communication interface. Now the second one is vref cmax finish. This command closes any existing vref connections. The -1 argument tells it to close all connections. This is a good practice to ensure a clean slate before attempting a new connection. Whereas id equal to vref samx start, this is a coordinate different. We have given the coordinate. It attempts to establish a new connection to the vref simulator. So here it's the detail has been explained, so you can go through it while designing. Now I have come in MATLAB next patch of command. So here this is a command if MATLAB if id is less than 0 display failed connecting Mode API server exiting. So this is a command. So here it is showing if ID is less than 0 means if it's -1 it means the connection failed, and it will display this message to the MATLAB command window, and vrep.delete deletes the vrep remote API object and cleaning up the resources, whereas returns exit the current function or script. Now go moving on to the next patch of command. So this is the next patch. Okay, so this section is about obtaining handles to various objects within the vrep simulation. And because it is essential for a unique identifier that allows MATLAB script to refer to and control specific objects like joints, keywords, table frames, and the gripper in a simulated environment. So if you remember, I show you the model, so from that you can relate. Now moving on to the next page patch. So here if you see, this is the next patch of command. So this is basically command related to handle for the UR10 robots joints what we saw in the model in the beginning. So it handles struct ID, it initializes MATLAB structure named handles, and this structure store all obtained object handles, making them organized and accessible. And it immediately stores the vrep client ID in it, which we have given in the beginning. Joint names are given in the second command, which defines sales array containing the name of the UR10 robot 6 joints. Then handle.ur10 joints, it pre-allocate one 6 array within the handle structure, and for I equal to 1 is to 6 it and a loop that iterates through each joint name. So here the more detail is given, explain like what are the different things it stand for: ID, joint name, vrep, res handles, vrecheck, vrefs. Now hoping these all parts are clear. Now moving on to the next part. So here for this section, what we are trying to do, let me explain. If you So this section is similar to joint handling, but it obtains handle for the three cuboid objects and three table objects in the same. So if you see, we have three objects, red, blue, green. So it also contains reference for that. So here it is like cuboid name, table name, all those things are there. You can relate. That's why I show you in the model in the beginning. Now, if you come to the this parts, so this part is basically it block get handle for the URL10 robot based reference object and a specific connection point on the robot. So it is like gripper attachment type of thing, and this explicitly state that these handles are not used in the simulation. Now moving on to the next patch, this so it's to get the handle for the joint that controls the gripper's opening and closing mechanism. The name RG2 open close joint suggests a robotic RG2 gripper. So that is what it means. Now this is if we small, its section initiate streaming for various object properties from VRAP to MATLAB. Let me check the connection. Okay, it is going on. Now I am coming to see this portion. Okay, coming down. So we have a big patch of MATLAB command. So it is basically a loop which initiates streaming for the position and orientation of each cuboid and each table, all relative to the handles. So if you see like where are the positions of two tables and where cube is placed and where you have to transfer the cube. So all those things are defined in these loops, and we have detailed explanation of what each of those function means. Now moving on to the next patch. So here if you see, okay, we are getting a big patch, and basically this block H4 commented out. It shows how one could stream the position and orientation of UR10 reference and UR10 gripper objects, but the authors have explicitly noted no need for them here, implying they are not used in the current pick and place logic, what we saw in the model. Now for this is a small patch which initiates streaming of the joint for the end gripper, which is crucial for controlling or monitoring the gripper state. Now coming on to this page, it is a loop which initiates the positioning, streaming of the positioning for each of the UR106 joint. Now this important position which starts the VREF simulation and ensures that the initial data has been received, means what we are trying to achieve through the simulation and what we saw in the model. So these are the two things that basically covered. Now coming on to the next patch, so here it's more of positioning and loop combination. So it is the main simulation setup and initial robot positioning. If you see in what is the initial robot positioning, through this it is defined. It's so here the coordinates are there, and then different where it is going to pause, so how its handle starting joint will behave. So all these things are covered in this. Now moving on to the next patch. So here this patch set up initial parameter for the pick and place sequence with the red, blue, green, how it will pick, what will be the sequence, like whether it's first red, blue, green. So here you can define that. Now here it is giving the first sequence. So this block describes the first pick and place sequence. It calls to custom function, that is go and catch cuboid, go and leave cuboid means it catch and then it leave. So hoping you relate these things. Now coming on to this, so here this block reset the cuboid to their original starting position, means once like we pick it and then it place it. So this is help to initiate this helps to cuboid to regain their original starting positions. So here like we explain what are each of them mean, what we have used in the function, so one can easily understand through this. Now second sequence means second block, same what we have explained earlier. So hoping you understand and you enjoy how to do it. Now finally, what is the summary of the script that I have explained? It will how it make the connection, how it handles the object, how its data is streamed, explanation of robot kinematics. I also show you the model. Important is like how you'll connect different libraries. So all those things are extremely important. So friend, if you like the video and if you need our help in doing any MATLAB task, you can visit our website given in the comment section, and contact us through WhatsApp also. And if you like this video, please subscribe it. Thank you. Have a good day.